So in this video, I will go over some examples using kinematic equations to help ourselves get familiar with how to use kinematic equations to solve kinematic problems. So as we discussed, that's the general strategies. First, we need to identify what are the quantities that are known. So we need to know at least 3 of them, and then we can find the equation which contains 4 variables, 3 known, 1 unknown, so we can solve the unknown from the kinematic equations. So let's look at the first example. We have a car traveling at 14 meters per second. The driver sees a traffic light at t equals 0, and it takes him 0.5 seconds to brake. After he brakes, the car has an acceleration negative 6 meters per second square. Now it shows the acceleration is in the opposite direction of the displacement as well as velocity. So what is the total stoppage distance for the car? So before the driver brakes, so in this part he's doing uniform motion, so his velocity is a constant, so it'll be fairly easy to find this distance. Let's call it x1. So x1 is velocity times time. Now velocity is 14 meters per second, time is half second, so it's 7 meters. And then from here, after driver brakes, this is constant acceleration motion. So the acceleration is negative 6 meters per second. So for this one, let's check what are the known quantities. So we know the initial velocity 14 meters per second, acceleration. Is there anything that we should know? So it says in the end the car should stop. So actually the final velocity should be 0. So we know 3 quantities. Which means we can solve it. It asks us for distance, and let's call this distance x2. So what is displacement? So we need to check which equation contains those 4 variables. Initial velocity, final velocity, acceleration, displacement. Okay. Now it seems to me this one, as I said, my favorite equation contains those variables. So we can solve for displacement x2 using this one, which is final velocity square initial velocity square over 2a. Now it's so we have final velocity which is 0, so it's negative 14 square over acceleration is 6, so it's 12 in the denominator, and acceleration is negative, so in the end you should get a positive number. So if you plug everything, this gives us 16.33 meter. So the total displacement from the instance the driver sees the red light to where the car stops, x should simply equal x1 plus x2 equals 23.33 meter. Okay. Now the next example is also an airplane taking off. Now this time we know the takeoff speed 75 meters per second, and the length of the runway roughly 1000 meters, and is a constant acceleration. It asks us what would be the minimal acceleration required for the plane to take off. So what are the quantities that we know? We know final velocity, 75 meter per second, and displacement. Now, anything else we should know? That there are only two quantities, not enough for us to build an equation. We did at least three. So don't forget, in this case, initial velocity is 0 meter per second. So we have three now. We have three known quantities. It asks us for acceleration. Now which one? Which one contains initial velocity, final velocity, displacement A? Is also this one. So we can simply solve for A. Is final velocity subtract the initial velocity over 2 displacement. Will simply give us, if you solve it, give you 2.68 meter per second square. Now we have a car which is speeding at 50 meter per second. It passes a police car which is driving at 40 meter per second. So you have a speeder is driving 50 meter per second, and the police car is driving 40 meter per second at time t equals 0. And let's assume their position are both 0 meter. So at t equals 0, both those two cars are at position 0. Now the speeder will continue at a constant speed motion. The police car accelerates with a constant acceleration of 3 meter per second squared. We want to know how long it takes for the police car to overtake the speeder. So we want to find the position of the speeder as a function of time, because the speeder is doing constant speed motion. So its position would simply speed times time as a function of time. Now for the police car, is initial velocity of the police car, which is 40 meter per second, times t plus 1/2 at squared, because it's doing constant acceleration motion. So that's the position of police car. If you want the police car to cut the speeder, it has to be xp equal xx. Then they're at the same place. So you have an equation. And then you solve for your t. Looks like a quadratic equation, but you have a t at each term. Actually, you can kind of eliminate them. So it's actually a first order equation. If you solve it, you find it's actually 6.77 seconds. So that's this example. Now the next example, we have a superwoman wants to jump on a truck. The truck is driving towards a bridge. The bridge is 10 meters tall. So if the truck is already under the bridge at the instant Superwoman jumps, there is no way she can jump onto the truck, because it takes some time for her to get to the drop this 10 meter. So she has to jump to estimate where would be the truck that she has to jump so she can land on the truck. When the truck is doing constant velocity motion, 18 meter per second, and she's doing a free fall basically, so we want to know this distance that she needs to jump. Okay, let's solve it. So basically we require the time for Superwoman to do a free fall for 10 meters. So this time should be equal to the time for the truck to travel this distance. So T Superwoman has to equal to truck. T Superwoman has to equal T truck. Now because this distance is 10 meters, we actually can solve for this, the time for Superwoman to drop. And we'll simply use this one. So in the y direction, actually it will be theta y equals, and we choose down to be positive in the y direction now, if you notice. Initial velocity of Superwoman in the y direction times t plus 1/2 at squared. And we all know for free fall, acceleration would be g, and it would be roughly equal 9.8 meters per second squared. And the initial velocity of Superwoman actually is 0, so this term is 0 because initial velocity is 0, 1/2 gt squared. And we know this one is 10 meters. This is 9.8, so we can solve for t, which is 2 theta y over g. And if we solve for it, it's roughly 1.43 seconds. Now, the time for the truck to move this distance, horizontal displacement theta s, has to be this time as well. So it's velocity of truck times this time give you this distance which we are looking for. So it's 18 meters times 14.3 meters. In the end, we have 25.7. So in the next slide, just give you a much more neat typed solution for this problem. And that's all the problem I want to discuss. And just see you next time. And good luck for your exam.